Now, class, we're about to do section 4.2, section D, divisibility and prime factorization. There's another way to find the prime factorization. This way is called divisibility. Divisibility is a number that divides evenly, no remainder, into another number. In the chart below are a few of the divisibility tests using prime numbers. Now, you can read this at your leisure, but typically 2, 3, and 5, most of the numbers you're going to encounter, 2, 3, and 5, those numbers are divisible by them. If any of the numbers are even, you can divide it by 2. If you add up the numbers, like for instance 78, you add the two digits together, that gave you 15. If the two digits after being added together give you a multiple of 3, then the whole number is divisible by 3. Just like this, 222. That doesn't look like it would be divisible by 3, but if we add the digits together, that gives us 6. So that means 3 would go into 222 evenly. Now 5 is divisible by 5 if the last digit is 0 or 5. Okay, now there are some other divisibility tests, but these do not use prime numbers like 4, 6, and 9. Now with 4, if the last two digits are divisible by 4, which means if they divide evenly into 4, like say we had 304, the last two digits is 0, 4. Doesn't 4 go into 4? The answer is yes. Or we have 148. We'd take 48. Does 4 go into 48? The answer is yes. So we could divide 4 into 148. And then 6, if the number is divisible by 3, like when we did 222, when we added them up, it equaled to 6. Now this has nothing to do with the divisibility rule of 6, that it equals 6. The main thing is it must follow two things. If it's divisible by 3, which this is, and if the original number is even, and it is, so then that means that this is divisible by 3. Like 78, 78 started off as even. You add the two digits together, it gave you 15, so it's divisible by 3. Now 9, if the sum of its digit is divisible by 9. So it basically follows the same rule as 3, except for when you add the digits together, they must be divisible by 9. Now these are some rules that you could use to help you solve certain problems. So I'm going to go through a few of these problems that should show you this here. It says find the prime factorization of the following numbers using divisibility. So we'll take 222. Now we know definitely that 2 can divide evenly into this. So it'll be 2 times 111. So that's a prime number. Now if we look at 111, if we add all of these digits together, that gives us 3. So we know 3 go into 111. So we add 3 times, so we could go off to the side. 3 goes into 11 3 times. 11 minus 9 is 2, and bring down your 1. 3 goes into 21 7 times, and we have no remainder. So it'll be 3 times 37. 3 is prime, and 37 is also prime. So the prime factorization of 222 is 2 times 3 times 37. Now, we come here to the next problem, 28. Now 28 is even, so we know 2 can go into it, and 2 times 14 is 28. But we also know that 14 is even, and 2 can go into 14, so it'll be 2 times 7 is 14. So we add 2 times 2 times 7. Now we scroll down here, 56. It's also an even number. So we add 2 times 28, there's 2. And 28 we could break down to 2 times 14. And 14 breaks down to 2 times 7. And see how the divisibility rules make it easy for you, because if you know it's even, automatically you know 2 goes into it. If you add those digits together and it gives you a multiple of 3, 3 goes into it. And if it ends in a 0 or 5, that 5 will go into it. So we could take 30. Since it ends in 0, let's just take 5. We know 5 times 6 is 30. Now we could break down 6 to 2 times 3. So we'll write this. We add 2 times 3 times 5. And that will be our prime factorization of 30. Now we go here to number 5, 72. We know 2 times 36 is 72. 36, if we add the digits, well, first of all, we can still divide this by 2 because it's even. So it'd be 2 times 18. And 18 breaks down to 2 times 9. And we know 3 goes into 9. 3 times 3 is 9. So our final answer is 3 2s and 2 3s. Now we got number 6, 117. Now we know 2 and 5 does not go into this, but let's try 3. 1 plus 1 plus 7, that'll give us 9. So we know 3 goes into 117. So now we could take 3 into 117. 3 goes in 11 3 times. 11 minus 9 is 2. Bring down your 7. 3 goes into 27 9 times. And you have no remainder. So 3 times 39. And 3 goes into 39 13 times. So you'll have 3 times 3 times 13. That is your final answer.